then the only difference is the information is in a table. So let's make a simple little table as an example. So let me just open up something like Excel. So as an example, we'll pick something like male, female, smoking, non-smoking, or something like that. Once my Excel opens. Here we go. So with these tables, come on. Or actually, maybe we can make it more realistic. Maybe we can use people in the room. We'll do that later, maybe. Okay, so on the top, for example, is if you're a smoker, or if you're a non-smoker. And then on the side here, and on the side here, male, female. So for example, in this group of people, maybe there are 25 males who smoke and 5 females who don't smoke, and then maybe there are 10 men who don't smoke, and maybe there are 15 women who don't smoke. So this is what I mean by a table. We have all the information in a table. So this one here, this would be females who smoke, males who smoke, males who don't smoke, and females who don't smoke. So this is our group of people. Okay. So to start, just write this down as a draw this table, please, to start, and then we'll have a look at some questions. Okay. Got that table? Oh, yes, okay. Got the table? Yeah. Okay, so let's start off with some simple questions I could ask you about this group of people. So the first thing I might want to know is how many people there are. Well, how many males are there? 35. And how many females are there? 20. So the total? 55. Now you might be wondering, well, what about if I count them as smokers and non-smokers? How many smokers do I have? 30. And how many non-smokers? 25. And if I add them together, I still get 55. So this number here is the sum of these two. This number here is the sum of these two. This number here is the sum of these two. And this number here is the sum of these two. And if you add these two, or if you add these two, you get the same answer, which is the total. So we have 55 people here. Okay, so my first question will be something like probability that you'll pick a male. So you pick somebody from this group. What's the probability that they'll be male? What would that be?
35.
It would be 35 over 55. 7 over 11. No, don't do that. There. 7 over 11. Okay, what about something like probability of being female? What one would that be? Well, yeah, it'd be here 30 over 55. Female 20 women. 20 over 55, or it's the same as 4 over 11. No. 4 over 11. Now I didn't say this last time. Well, I didn't say it explicitly. I didn't say it at all. But I think you kind of have this idea already in your head that if you want the probability of male, female, whatever, and then if you want the probability of not this, then it would be 1 minus the probability of having it. Right here. So did I say it?
You said it like the total is 1.
The total. Okay, I believe you if I said it. I don't remember saying it, but it's good I said it then. So here, where's my mouse? Oh, there it is. My pad's not working, of course. Probability of not A. So we put a little tick here to mean not A. So A could be winning the lottery, going to school, picking a red ball, whatever. So probability of not A is 1 minus, does anyone know this one? Probability, this looks so ugly. Probability of A. Let's see if I can fix this. So you can see that working here. The probability of getting female is the same thing as probability of not male, which is 1 minus probability of male, which is 1 minus 7 over 11, which is the same thing, 4 over 11. Okay, we're working now. So probability of not A is the 1 minus probability of A. And often we write not A shortly like this. So for example, probability of female, that's the same thing as probability of male, or not male I should say, which is 1 minus probability of male, which is 1 minus 7 over 11, so you see you get the same answer, 4 over 11. Okay, so let's try and make these tables a little more difficult. Can I go back to the table? Yeah. Yes? Okay. Right, so let's say now my next question, well, we might as well do it. Probability of smoker, getting a smoker, what would that be? Let me see, that would be 30 over 55, which is 6 over 11?
Yeah.
Which is 6 over 11. Okay, and then probability of not a smoker should be 1 minus 6 over 11. So, what's that now? 5 over 11, isn't it? 5 over 11. Okay, so now I'll make it a little bit more difficult. I want to write down exactly what I want. You got that part? Right, so this time I want the probability that a man picked at random. Yes, I saw it. Not random. A man picked at random will be a smoker. So now we're only picking from the men, and we want to know what's the probability that that man will be a smoker. So there is a way to write that using my P symbol. Does anyone know how to write it? So you want smoker, but you only want it to be from the men. So do I write smoker and man? Smoker plus man? Smoker or man? I mean, what's the... Or maybe it's symbol like this, a symbol like this, if you know them. Anyone know? You're thinking this? Yeah? Anyone else? It's actually this. So what this means is, this is what you want. This symbol here, this line, means given that it was a man, or you know it's a man, or you want only the men. So I would read this as, what's the probability of a smoker given that I know I'm choosing from the men? That he is already a man. Do you understand the symbol here? So this means given that, provided that, you know that, all these meanings. Okay, so let's go back to our table and see what we get. Or you need to write it down actually. Now we'll talk more about this in the next semester, but just for now I just need you to know what this symbol means. It means given that, provided that, he's already a man. Okay. So here I want to know probability of getting a smoker, given that you know it is going to be male already. So this changes, the smokers are still 30 smokers in total. And this is how many smokers you have. That's not going to change. How many men do you have though? How many men? 35. So instead of having 55 in total, you have 35 in total. So you're only choosing from the men. There's 35 men. How many smokers are there?
25.
Yeah, sorry, I keep saying how many smokers, but I should be really saying how many male smokers. How many people are there that we want? How many male smokers? So there's 25 male smokers, and there are 5 female smokers. Yeah, so you have 25. Sorry, it's not 35. No, you said it was 35 smokers. It's not. Sorry, there's 30 smokers. 30 smokers. 25 of them are male, 5 of them are female. So of the 30 smokers, no, hang on, just 1 second. Okay, yes. I don't have enough yet. Right, so as I was saying, yes, there are 30 smokers, but I don't care about that. I care about how many men there are, because I'm choosing from the men. So I need to picture, I have the room of men. In this room of men there are 35 of them. And of those 35 men, how many of them smoke? 25. So it's 25 over 35, which is 5 over 7. Okay, and let's do the same thing except with the women. So probability that you get a smoker given that you're choosing from the women. So in this room of only the females, how many females are in the room? 20. And of those 20 women, how many of them are smokers? 5. So it'll be 5 over 20, which is 1 over 4. 5 over 20, which is 1 over 4. Oh, look what it did. 1 over 4. There. Ugly, but you get the idea. Okay, what about this now? I want you to try this one for me. So I want to know the probability that I get a man if I'm picking from the smokers. So what's the probability that they'll be male if I'm only choosing from those who smoke in my group? Yeah, what do we think it'll be? Yes, that's what I was thinking a minute ago when I was getting confused. 25 over 30. There are 25 men in the group of 30 smokers, which is 5 over 6, yeah. Okay. This.
Is it like the same meaning when you say man and smoker?
Yes, good. Let's do that one now. What's the probability that I pick a man and smoker. So yes, as you were saying, Malik, it doesn't mean the same thing as this, and it doesn't quite. So this here probability of man and smoker means I pick someone from my group and they are a male smoker. Maybe I'll write it like that. Probability of getting a male smoker, man and smoker. So how many men smoke? 25. And how many people are there altogether? 55. So this would be 5 over 11? Yeah. What about probability of getting a female smoker? What would that be? It would be, yeah, 5 over 55, which is 1 over 11. Malik, is that okay? You can see the difference between these two, or not?
Yeah.
You can see the difference? Yeah. Okay, so this is kind of a basic example just to get us used to the vocabulary. So let's do another one a little bit more difficult. So when you're ready, I want to delete this. So we've done male, female, smoker, non-smoker, a smoker among the males, a smoker among the women, probability of getting a male smoker, probability of getting a female smoker. Okay, I need to delete this to make more space. Can I delete this? Yes? Okay. Okay. So let's say there are 3 ways the students can get to school. They can either walk, they can either cycle, or they can either take the bus. So for this school, maybe 40 boys walk, and maybe 40 girls, or make it different, 35 girls walk to school. Maybe 45 boys cycle to school, and then maybe we'll say 20 girls cycle to school. And then for the bus, maybe we'll say something like 10 boys take the bus, 30 girls take the bus, something like this. So we have 3 different ways the boys and the girls can get to school. Okay, so write this table down. So the first thing I want you to do for me is to complete the table. And by completing the table, I mean to put in the totals down the side and down the bottom. And you got the totals? Yep. We'll wait a minute. Okay, so let's complete the table together. I'll go down the bottom here. So how many, actually maybe I'll make a different colour or something here. Right, so how many walk to school? 75. How many cycle to school? 65. How many take the bus? 40. So 40, no, sorry, don't want that bold. 40 take the bus, and then in total here there is 190. Oh. Oh, goodness. This plus this plus this, 180. Right. How many boys are there? 40 plus 45 plus 10, so there's 95 boys, and girls 35 plus 20 plus 30, so 85 girls. So in this school there are 180 students. Okay. So the first one I want you to try for me I want, oh, open again. We're back. Right. First one I want, as you pick a child at random, and I want to know what is the probability, let's make it easy to start with. So probability that you'll get a girl. Then the probability that you'll get a boy. Then I want probability that you pick somebody who walks to school. So girl, boy, and then walk. The last one is you pick somebody who walks to school. Okay. How many girls in total? Sorry, yeah, how many girls in total? 85. And how many students in total? 180. So what's this? 17 over 36. Well, this should be 1 minus 17 over 36 because, as you know from Pokemon, you are either a boy or you're a girl. So 1 minus 17 over 36, being boy means not girl, so this is, what is it? 19 over 36, good. How many people walk to school? 75. So you have 75 over 180. Oh, sorry, the projector's up a little high. Nobody said anything. This is 5 over 12. Okay, now let me give you some more that's a little bit difficult. So I'll write it in words, and then what I want you to do this time is write the symbol part as well. So I want probability of getting a walk-in boy, a boy who walks to school. Yes, I know it sounds silly. What else now? Well, actually, let's just do it one at a time. So, yeah, just give me this one then. Okay, so this one here would be probability of somebody who's walking to, so we need to imagine that this is the morning because I said walking, present continuous. So we need to picture that it's the morning time, it's 8 a.m. What's the probability of getting a walking boy? So how many boys are walking to school? You're looking for someone who's walking and who's a boy. So how many boys walk to school? 40 over 180. So what's that then? 2 over 9. Okay. So let's make it now a little more difficult. Probability of getting a boy from the walkers. Okay. Got this done? So, what do I need to write here? Boy, given that you're only looking at the people who are walking to school.
Is it the opposite?
No, it is this way round. A boy from the walkers. So you are looking at only those who walk. So that's the reason it's here. Okay, so how many walkers are there? 75. And how many of those are male walkers? 40? So what's that now? 8 over 15. Okay. A walker from the boys. Okay. Got this finished? So this is probability that you'll get somebody who is a walker from only the boys. You're only looking at the boys. Oops. So that would be, let me see, how many boys are there? 95. And how many of those? 40, is it? So that would be 8 over 19. So notice how that's quite different to this answer here. Okay. Right. One more and then we'll do another example. So this time I'll say a student is picked at random from those who take the bus. What is the probability they are a boy? Okay, try this one for me now. Okay. So firstly, this would be probability of boy given that they took the bus. So how many students are on the bus? How many students take the bus? 40, is it? And how many of those students on the bus are male? 10. So you got a 1 in 4 chance. Okay. Can I go down? No? Okay, so let me give you another one. Make it a little bit more difficult. So this time I'm going to give you the table. It's a table. No, I should do it better than that. I'll go back to this. Can I delete all of this? Yeah. Alright, so what you've got here, you ask men and women, so you can be male or female, do you like to drink tea, coffee, or neither tea nor coffee? So of the men, 2 of them said they like to drink tea, and you don't know how many said they like to drink coffee, but 6 of them said they don't like to drink tea or coffee. And then with the women, 5 of them said they like to drink tea, 3 of them said they'd like to drink coffee, and you don't know how many of them said they don't like to drink either. But I also tell you that there are 12 women in total, but I don't tell you 12 men in total, but I don't tell you how many women there are. I also tell you, of course you can see that 7 people here like to drink tea. I don't tell you this, but I also tell you that there are 25 people in total. So okay, of course you know that this number here must be 7, so I'll just leave it like that. So what I want everybody to do for me first is to complete the table. Finished? Yeah. Okay. So which is the easiest one to fill in first? Well, that's this one here. That you know there must be 7 people. Maybe I'll use a different colour. So there must be 7 people who drink tea. Now you know 12 of them are male. 6 of them don't like tea and coffee. 2 of them like tea. So that means there must be 4 people here who like coffee, because it's the only way to make 12. So there must be 4 here. Okay, so let's see. There's 25 people in total. 12 of them are male, so that means 13 of them must be female. Oops, no, I don't want to do that. No. Oh, doesn't matter. There you go. Whatever. Right. 13 of them must be female. Okay, well, if there's 4 men who drink coffee and 3 women who drink coffee, there must be 7 people who drink coffee. That's fine. And let's see now. If there's 7 people who drink tea and 7 people who drink coffee, that's 14. So there must be 9 people here who don't drink tea or coffee, right? Isn't it 9? No, it's not. I won the wrong way. 11 people here who drink coffee. Okay, so if 11 people don't like tea and coffee, 6 of them are men. So that must mean 5 of them here must be women then. So what I'm trying to show you, let me clean it up a bit. I only needed to give you 1, 2, 3, 4, 5, 6 numbers, and that's enough to complete the table. And sometimes they do this in the exam. Sometimes maybe it feels like they haven't given you enough information, but actually when you start writing it down and thinking about it, you realize, oh, you have enough information to complete the table. Okay, so my question now, let me write it down. Well, first, if you need to copy the table, do that. So actually, maybe I'll put the, no, I'll write it down. I'll go back to the table if you need to. So I want to know the probability that a person who is drinking tea is a woman. So I want to know, so maybe I should maybe make it a bit more explicit. When I say here people who drink tea, let's say they only drink tea and nothing else, okay? And people who drink coffee only drink coffee and nothing else. They never drink tea. And the people who drink neither, you never see them drinking tea or coffee. We'll just make it clearer that way. So you have somebody who's drinking tea. I want to know what's the probability that they're female. Do you need me to go back to the table? So if you need any numbers from the table, no, okay. Okay, so first thing to do is just to write it in a more compact form. So what do I have here? Probability of, now yes, which is first? Female or T? Yeah? Oh, okay, so is the person who is drinking tea is a woman. So what you know about them is what? You know that they're drinking tea. So you want the probability woman, given that they are drinking tea. You know you're looking at a person who's drinking tea. If you picture this in your mind, you know they are a tea drinker. They are sitting down drinking tea. You want to know what is the probability that that person, you should picture them as female rather than male. So we have to be very careful with the English here. So although woman is at the end, it's actually at the start in here, because this is what we are given. A person who is drinking tea is a woman. So the sentence, I know it seems like it's backwards, it's probability of a woman given that they're drinking tea. You know that they're drinking tea. Marcelio, is this an English thing or a maths thing, or?
I don't know.
No, tell me what you're thinking.
Only woman. That's right.
So you're thinking that a person who is drinking... Right, okay. So the small change I would need to make it like that. Yeah, I would need to... Let me show you. It's good for English to show you the small changes. So if I said a person who would be drinking tea from the women. Now it's exactly what you said. So grammar, yes, we need a little bit of grammar for this chapter in maths. Okay, so make sure you read it twice before you, at least twice before you do it in the exam. Okay. Right. So how many tea drinkers are there? 7. And of those tea drinkers, how many of them are women? 5. So we have 5 over 7. Is the probability that the person drinking tea is female? Yeah? Okay, let's see, is there anything super tricky? I don't think so. So again, you can do these for 5 minutes, okay, and then I'll let you go. So for 5 minutes, I want you to do some of these. And I want all of these done as well. Now, when's our next class?
Next week.
Monday, is it?
Yeah.
Right. So
Just worry, we have another week after.
No, I'm not worried about the time. What I'm worried about is people not doing their homework. So Monday's class, I'm going to check the probability homeworks, okay? And I'll be quite angry if you don't have it done by Monday, because that's lots of time to do all of these questions. You have Thursday, Friday, Saturday and Sunday to do all the probability questions. Okay? Right, so you can start them. You probably will get a lot of them done in 5 minutes because they're not so long, okay? So see how many you can get done in 5 minutes, then you can go.